Guys, to part 2. This is on page 3 of day 8. Now, I'm not going to lie to you. This is where it can get a little confusing. So pay close attention because we're moving away from bisectors, and this is talking about 2 other definitions. So our 2 other definitions on this page are going to be these right here. We have the altitude of a triangle to start. And whenever you think of altitude, there's one word I want to come to mind here. I want you to think of height. Altitude is the height. And remember, height has to be straight. Straight up, as Travis would say. Altitude is going to be straight up vertical height. And if it is straight up height, that means it's going to be perpendicular. Check that out. We would say on this one, line segment MN is an altitude. Sometimes I call it a tude. Altitude, wow, tude, that's a D. Call it tude for short sometimes. You can see it right here. Notice how it forms that right angle. And notice it does not cut this in half. Not split in half. So keep that in mind. With altitude, it does not have to go down the middle. That's not the case. It is the case for our next one, though. The median of a triangle. Now, median, a lot of times we think middle, right? Like the middle number when you find the median of a set of numbers. So it kind of plays along here. So median is a segment starting at the vertex. So once again, boom. Got to be going through our vertex here, at least a vertex. We see that right here. And it's drawn to the midpoint. So there's where middle comes in. So we're still cutting things into halves when it comes to medians. We see here that we've got this piece and this piece are halves. But notice, not necessarily perpendicular. No right angles. Keep that in mind. It's cutting it in half, but it could be coming at it from an angle, any kind of angle here. And so let's look at just a couple here, guys. Or actually, let's look at one, and then I want you guys to try maybe one on your own here. So let's look at number 1 together. So find FT if FG is 6.6. So this whole stretch is 6.6. And check it out. Each figure shown is a triangle with one or more of its medians. So this right here is a median. And if there is a median, we know it's not going to be a right angle, but it is going to start at a vertex, E, and it is going to cut the other side, midpoint of the opposite side. So boom, that means that's half, that's half. Well then, if this whole thing's 6.6, if we're going to find FT, divide it by 2. And it'd be millimeters. 3.3 millimeters there. So we want to define that. And so what I want you guys to do, once again, we're dealing with medians on this one and on this one. I want you guys to try number 2 for me. Try number 2. Once again, make sure you label first thing. And make sure you know what you want to find. We want to find x, and we want to find ON. So 7x minus 20 is the whole piece down here. OM is going to be 3x plus 8. So I'm going to let you guys see if you can try this one. You can go ahead and pause the video. Okay, so to start, you're probably looking at this and going, wait a minute. Some of us may be saying, wait a minute, where'd 6x plus 16 come from? I know 7x minus 20 is this whole thing down here. Wait a minute, if this is 3x plus 8, wouldn't that also be 3x plus 8? 3x plus 8 multiplied by 2. Pretty much just double 3x plus 8. That plus that is going to give you that. So that's where that came from. Subtract 6x over, that gives you 1x. Add 20 over, that gives you 36. So we found x. From there, we just need to find ON. We know ON is really 3x plus 8. So 3 times, not x, but 36 plus 8. Multiply and add, that gives you, I believe, 1 16. You can double check me, but I feel pretty good that that's going to be 116 for this side, which means this side's also 116, which I guess would make this be 232. All right, so the last page, guys. Ooh, this is a long day, isn't it? Almost through. Let's keep that smiley face going. We got this. All right, so now let's put this all into practice, guys. Let's see what we've got. So in triangle MNP, ooh, check this out. MO is at not only an altitude, right angle, not only a median, through the vertex, cuts it in half, not only an angle bisector, this angle split into equal pieces, it's also a perpendicular bisector, which means it comes right down, right angle, split into equal pieces. Man, this is, which also means that because M is on this, M and O, from N to M and P to M, that would also mean these are congruent. So check out all the things we can say about this triangle, just based off knowing that MO is all four of these things. Well, if that's the case, check it out. What's MN? Oh, well, MN, it's going to be the same thing as MP. Those are the same, so I can set those equal to each other if I need to figure that out. So 6x minus 1 equals 3x plus 8. Subtract 3x over, add 1 over. 3x equals 9 divided by 3. Okay, x equals 3, but remember, that's not what I wanted to find. I wanted to find MN. So then I pull that over here, plug 3 in for that. Turns out MN is going to be 17. Okay, well, how about this next one? If NO is 8, so if this is 8, find OP. Oh, wait a minute. NO and OP are the same. So that's pretty easy. That would be 8 also. And NP. So the whole piece here, well, 8 plus 8, going to be 16. And then, last thing here, if NMO, so this piece is 36 degrees, find OMP, that would just be this piece, which these are bisected, so they're the same. So that's 36. NMP, that's the whole piece. That whole thing is going to be 72 degrees. And MNO, M to N to O. Okay, now that's where this part gets a little bit trickier, or you would think. If this is 36, and we know this is a bisector, that means that has a right angle also. And if we know that's 36, and we know that's 90, MNO is our third missing angle. So 180 minus 36 minus 90. And when you do the math, I believe you end up getting 54 degrees for MNO. And so what I'm going to let you guys do, I'm going to give you a chance. Let's read over this fact. And then I want you to answer questions 1 and 2. So based off everything we've talked about, we got kind of some facts and some good questions to end today. So try 1 and 2 for me after you've read our big fact here. Go ahead. Okay, so we know a triangle has 3 altitudes. That means it's got 3 different ways to measure its height. Now, 2 of them are usually only going to be sides. The only time that all 3 are actually inside of a triangle, but 2 of them are sides, is in a right triangle. Check it out. Here is an altitude. Turn it sideways, or like this. Here is an altitude. But then where's the third altitude? Because this isn't an altitude, it's diagonal. Oh, wait a minute. What if that's our base? Boom. And then I drew. That could be an altitude as well. There's your third. straight up from the base, goes through a vertex. Now, sometimes altitudes can exist outside of a triangle. That's when it gets kind of wild. Check this out. Here is our triangle. Boom to boom to boom. There's our triangle right there. But here are our altitudes. Check it out. So this is an altitude. Okay. So again, if you can't remember, median, AC, goes through the vertex, hits on the other side and creates halves. An altitude, vertical, straight down, creates a right angle. And then, of course, a angle bisector is something that splits angles into halves and cuts through to split and make equals even sides here. So, which one is this first one? Comes through a vertex, not vertically, does not create right angles, hits and creates parallel or congruent sides. That is a median. So these are medians. How about this next one? Goes through the vertex, hits, creates right angles, does not split into halves. So that's definitely going to be an altitude, set of altitudes here. And then finally, we already see these angles being bisected here. We also see that, yep, cutting through. So this is angle bisectors. And then the final thing, guys, before we wrap up today, fact number 3. The altitude, median, and angle bisector from the vertex angle to the base of an isosceles or equilateral triangle, here's the key, are always the same segment. So what that means is, if you have like an altitude, a median, or an angle bisector, it's always going to create these congruencies with sides to connect like that. The points on this bisector, we know the distances are going to be congruent, as are the angles. And we can see here, 2 sides are the same for this big triangle. That's an isos. How about this one? All 3 angles are the same. That means this is going to be equilateral. Also, it'd be isos, because isos means at least 2, maybe 3. So that works too. Also, you could say 60, 60, 60. This is an acute triangle too, but we're just getting kind of petty at this point. And then, of course, we see the angle bisector here. Splits these into the same. They would really be 60. So there you go, guys. Well, thank you very much for sticking with me. I know this is a longer day, but you guys did great. Your homework, we may have a little assignment over this tomorrow. We'll see. I want to see kind of how you guys do and get some feedback for you before I sign it. But our homework is going to be the practice multiple choice. It's on page 5 and 6. Page 5 and 6. I believe there's 7 questions. Hope you guys have a great rest of your day. Don't forget, test Thursday.